Absolutely, and thank you very much for having me here. Good morning, everybody. I guess I'll just jump right into it. First and foremost, if you are familiar with the Tower S Satellite Book Club series, I gave a similar talk to that group. If you're not getting those emails, I would recommend checking them out because that was definitely a great series that they've got going on as well. Yeah, let me just jump into it. So why? Why marginal events in particular? I think it's a pretty straightforward answer for most, and that is that marginal events can be fairly challenging, especially when it comes to the warning decision-making process. A lot of times these marginal events aren't necessarily very clear-cut and obvious as some of those higher-end events are. So that was something that I wanted to focus on is how can we maximize GLM in the warning decision-making process. So moving right along here, just a quick disclaimer here. I'm not a doctor of lightning, so to speak, nor do I play one on TV. I definitely consider myself to be more of an enthusiast. With that said, though, lightning has always been something that has been of great interest to me throughout my career. I started out in Melbourne, where they've had a total lightning network down there for a number of years, and then there's a few of those ground-based networks that are scattered about around the country. So that to me was kind of like the door opener to lightning and that interest. Okay, so I'm going to give you some conclusions up front, and this was kind of talked about already in the last presentation. So that was great, and that was the discussion about mesoanalysis and the importance of having an individual or individuals perform this role. And I definitely want to give a shout out to the regional deployment of those mesoanalyst rooms. I think that that's going to be a great asset. And I saw that there was an event in the not so distant past where, you know, there was lots of conversation that was going on in those chat rooms. So, you know, whether it's in your office or somebody who is keeping an eye on things outside of your office, I definitely subscribe to making sure that there's a mesoanalysis role that is being played when we're talking about the warning decision-making process. It obviously helps to maintain situational awareness. Ideally, that should not be the radar operator. I'm sure many of us already know that, but the mesoanalysis should be somebody different from the radar operators so that the two functions are able to maintain better situational awareness. And then obviously communication between those two individuals or those two groups is absolutely essential. So using all the available tools and resources at your disposal, checklists can be helpful, and I will give you a couple of examples of checklists that we've started to use in our office over the last convective season. And then, of course, why I'm even here today. Lightning data does and can help. I just want to let you know right up front that that was definitely something that I had found over the years, but definitely when I took a little bit of a closer look at some of these events that we saw in the 2020 convective season. There's always going to be caveats, of course, and I would definitely recommend developing your own local thresholds and methodologies. I think that a lot of trends and similarities can be applied across the board. Doesn't matter what office you're at, whether it's Marquette or Dodge City. You know, I think that there's a lot of similarities that can be applied across the board. But I also think that it's important to identify what some of those local thresholds might be, because there are going to be some slight differences. Okay, so something else that I had found when doing this work is that it would be excellent to have more readily and easily available GLM data. It would be very helpful to have, my vision, my dream would be to have some sort of GR equivalent type tool for satellite imagery, especially when we're talking about GLM data. When it comes to GLM data, if you're not familiar with looking at some of that archived information, there is so much to digest and unpack. And of course, this is still relatively new to us in operations. So having some sort of way to really easily and more readily be able to view that data and go back and look at past cases and apply that GLM data would be very helpful for sure. And I do want to give a shout out to Ryan Connolly, who is a meteorologist here at this office. He did help me with some of the images that you'll see a little bit later in the presentation. and he's been doing some great work utilizing Python and unpacking some of that archive data. So shout out to him, thank you. Okay, the meso-analysis process is, again, I can't overstate it enough that this is definitely something that I think is important. Going back to those checklists, two of the ones that we've started to incorporate here locally, one is a modified version of a near storm environment checklist that was courtesy of Grand Forks. So thank you to them for sharing that with my Sue. And then another checklist that I actually picked up from my former office, Pleasant Hill, and I'll show you that here in just a second. And I just wanted to point these out, that these are things that we have found to be helpful here locally. And if you're not familiar with these checklists, might be helpful in your office as well. Just a note, most of our events, if you are familiar with either this category or that checklist, most of our events do fall into the Donovan method category. We can get some super cells and big hailers up here, but obviously not as more frequent as some of our plains offices, for example. And something else that I would recommend, that I felt I got some fairly positive feedback on, is someone in your office who is really tuned into lightning, or somebody who might be an enthusiast in lightning, and presenting that information to the staff, especially early on in the convective season. So if you've got your convective workshop that you're going to be planning coming up here this spring, it might be good to have somebody present on what the different lightning options are, and just kind of talk about and share with the staff some of the advantages to being able to incorporate lightning data into the meso-analysis and warning operation processes. Okay, so this is just a quick look at that checklist that I was just referring to. Again, this is from my former office, Pleasant Hill. And like I said, our hail generally falls into this 1-inch hail category, poor to fair. The Donovan method is what we've found works fairly good for us. And so there's lots of other good information on this checklist here. Definitely reach out to me or someone at that office if you're interested in finding out a little bit more about this particular checklist. Okay, so April 7th, 2020. I consider this to be the local event that started it for me down this path. This served as an inspiration in terms of me being able to determine if and how much GLM could really be incorporated into forecasting and the warning decision-making process for any subsequent events. And so here's a look at that near storm environment meso-analyst checklist, again, locally modified for us. On this day, we did have high shear. I wouldn't put it in quite the low Cape category, but low to moderate type situation is what we had there. And I've circled what I'd identified was going on for that day, kind of setting the stage for you. And if you'll notice here, there was some convection around, not a whole lot. We did have a blob of activity that had gone through the southern portions of our CWA a little bit earlier. And then you'll notice down in Green Bay's area, definitely some cells and convection that was firing up there, dropping some hail. And then we had this storm here that developed across the border in Wisconsin, and then just clipped us here and ended up putting down 1.25 inches of hail there. So that was really something that I wanted to take a look at. Was it possible that GLM could help us to have a little bit of a better lead time and have a little bit more confidence in the warning decision-making process? Unfortunately, I don't have any zoomed in localized GLM plotting for this particular event. But you can just take a very quick snapshot here. This is more of that CONUS view. And then I'll move up to the next one here. So there's definitely lots of lightning in the area at the time. And just anecdotally speaking, it did look like there was some correlation that could be drawn between this event, the lightning activity that preceded the event, and then of course the hail that occurred right after that. Okay, so June 2nd was an excellent case for me to really dig a little bit deeper into how can we potentially use and maximize GLM for these marginal type events. And this is the last event that I'll show you that kind of uses this mesoanalyst checklist. Again, I just wanted to give you a little bit of a snapshot of what made me determine that this is, falls into that moderate category, or marginal category, excuse me. So we had low shear, low mu CAPE. You can see what I've circled there, what I identified in terms of the environment for that day. So nothing screams out here saying this is going to be a big hail event. Absolutely not. There were only 3 LSRs that were issued, and only one of those 3 LSRs were severe. So definitely a lower end event. But nonetheless, it was still something I think that was important to take a look at. And this is just a picture of some of the hail that had fallen that morning. This is affectionately known as the bird streets. So thank you to our Opal for sharing this picture here. And I'm going to start out here, before I show you the GLM products, I want to just start out here showing you the Vaisala total lightning. And this is through the thunderstorm management page. If you're not familiar with that, you know, feel free to reach out to me afterwards and we can discuss it a little bit more. But for those of you that are familiar with it, you might be, you know, pretty tuned into seeing what you're looking at here. But essentially, and I'll play this through one more time, you can see the lightning activity that's starting to pick up, and this is fairly early in the morning. This is just after 6 a.m. You can see that lightning activity starting to spread, and this is, again, is total lightning, so this includes cloud to ground, intra and inner cloud lightning. You can see that really starting to tick up, especially as we get a little bit closer toward sunrise here, and then spreading into the Marquette area, and then to the points to our south and west. Okay, so looking at this product here, the total optical energy, and again, this was right around sunrise, so this was really cool to see that total optical energy product overlaid on top of visible satellite imagery. And you'll be able to see it here on the next slide. As soon as I go to the next slide, the color table allows it to be a little bit more obvious, but you do see an uptick in that lightning activity. So not only it's spreading out spatially, but also really starting to jump up, so to speak, right before that hail event ended up occurring. So flash extent density, this might be a product that much more of us are used to looking at. But again, you can really see that lightning that's starting to spread out across the area. And then you'll see a little bit more of that jump right before that hail occurred. So I had calculated about a little more than an hour overall in terms of the starting time for that lightning activity. And then I noticed the more significant uptick in lightning activity about 10 minutes before the LSR was issued. And the LSR was issued 11:58C that morning. And then just taking a quick look here at what radar had looked like that morning. And it'll pop up here in just a minute, but you'll start to see some cells that are starting to pop up out across the western portions of our area, and then it starts to move to the east-southeast here. And you'll see that really firing up, and it lines up pretty well with what we were seeing in terms of that lightning activity. And then something that I didn't really take that close of a look at, but I thought it was really fascinating watching it blowing up right over Lake Superior. You can see those hail reports, and then there's that activity right there at the tail end of that loop as it goes out over the water. Okay, so July 18th and 19th. This was a little bit of a bigger impactful event for us. I would not necessarily put this into the marginal category, but I still thought it was fascinating to take a look to see how much GLM could help us in the warning decision-making process. So this is looking at that total optical energy product, and you can see here that the lightning is fairly sporadic. It's consistent though, consistently going up and down. In terms of the spatial extent of it, certainly spreads out quite a bit. And I'll go back here for just a second. You can see that lightning, it initially at first glance looks like it's just all over the place. You're not really seeing any sort of patterns, but if you're paying closer attention to radar and you are utilizing this GLM data side by side with radar, you will notice that there are definitely some upticks in the lightning activity, constantly going up and down, so to speak. And it corresponded with and definitely was in line with what we were seeing on radar. Go through that one more time there, and this is flash extent density. Okay, so here's a look at radar, and our radar was actually down at this point. So we utilized Duluth's and Green Bay's radar for this. Essentially what you're looking at here is there's two different areas that I had focused on. There's this area here that's coming into the far southwestern part of our CWA, and you can certainly see the velocity speeds are quite high at that point. Let me go back here. And then there was another area here, a little bit further to the north of that area, that put down some pretty significant winds as well. And again, if you go back and look at that GLM data, you can really see that side-by-side view of the upticks with respect to lightning in these particular areas that we were monitoring, and then corresponding with some of those wind events that we were seeing at this time. All right, so August 26th was another event that really gave me an opportunity to dig a little bit deeper into GLM and incorporating it. The first one that I wanted to bring to your attention is just outside of Escanaba, Michigan here. If you could see my mouse kind of moving that around there. That is a lightning report, and I did want to show you for the purposes of what ended up happening here. Essentially, a barn was struck by lightning and it set on fire, causing extensive damage to the second story. So that was the LSR that we had received at 8:43Z. And so I did want to take a look at the lightning data to see, was there any way that, maybe I don't know, what we could have potentially done from a messaging standpoint, maybe just said that there's an excessive amount of lightning in the area, or whatever the case may be, but I still wanted to take a look at it. And so this is the energy density product, and this is courtesy of Sierra. And you can definitely see that there was quite a bit of lightning activity in the area during the 8Z hour. And then going on here to the next one, you can see a little bit more clearly the flash count density product really upticking in that area. So definitely lots of lightning activity in the area. So this was an opportunity that maybe we could have messaged just the amount of lightning that was occurring at that time. And then here is what the radar looked like. So this is not going to be helpful in terms of any sort of lightning messaging, but I just wanted to show you just, so that you have it in your mind of what we were looking at from a radar perspective. Okay, so let me go back here for just a second. The other one that we're going to focus on here is this hail report here, just under an inch that fell, nickel size hail. And this is an energy density product again, and it's a little bit more challenging to see on this product, but there is an uptick in lightning activity once again. And this was about 10 minutes is what I saw for a lead time here. A little bit more visible on this flash count density product. It's not as in your face, so to speak. It's not that bright red that's really sticking out to you. But again, if you have somebody who is analyzing this information, a mesoanalyst that's looking at this GLM data, you'll definitely be able to see that there is an uptick in lightning activity just before that nickel size hail fell. Okay, and then again, just taking a look here at the base reflectivity, what we were looking at for radar at this time. Definitely some convection in the area. And then you can see starting to spike up here in just another couple of frames. There it goes there. It's really starting to take off there. And then we ended up getting that nickel size report right after that. So good correlation for sure between GLM and radar. Okay, so August 31st, we ended up having a low top supercell develop and quickly spin up a tornado, and it only lasted for 2 minutes. It was very short in both length and width, but it did do quite a bit of damage. We ended up rating it an EF1. And then right afterwards, it ended up, the whole cell ended up collapsing and creating downburst wind damage right after this occurred. So what was very fascinating here was I wanted to, again, take a look at GLM data, and was there anything that was obvious ahead of time that we can correlate with respect to this particular event. And so I'm going to show you this product here, and I don't want to show you, but I do want to have you kind of take a look here and think to yourself, is there anything that's obvious on here? And initially the answer is no, right? So initially I kind of just, went past it and moved on, but then something did catch my eye. This is the energy density product. Let me go to the next product here. Let's see if you can see it in this one a little bit better. It's the flash count density product. And there was, sure enough, a little blip of lightning about 12 minutes beforehand that came up. So I thought this was a really interesting case here where there was actually lightning that did occur. Initially, we didn't think that there was, but I went back and took a look at it, a little bit of a closer look. And it's a little bit challenging to see, but it is there nonetheless, that there was some lightning activity about 12 minutes before that occurred. And then just taking a look at radar here, I don't have SRM or velocity here available, unfortunately, but you can take a look there. There's that tornado report popping up there. Okay, so wrapping everything up. So first and foremost, one of the biggest things that I got out of taking a look at all of these events was that there was clearly a quote-unquote jump that did occur in the lightning before each of these incidents occurred, and the average time was about 10 to 15 minutes. So like I said, it was sometimes on that lower end, sometimes more on that upper end, but on average, it looked like about 10 to 15 minutes ahead of time is when you started to see a little bit of that jump. So to me, all of this is just the beginning and just barely grazes the surface of really maximizing and utilizing GLM data. So one of the things that I want to continue doing is identifying these cases of interest, identifying ways that we can potentially utilize, maximize, and incorporate not just GLM, but other ground-based data, lightning data into our warning operations. And specifically, what can the mesoanalyst provide to the radar operator to help increase forecaster confidence in their warning decision-making process? What kind of lead times can we maximize here? So I really think that there's some pretty good potential here, and it's just a matter of digging a little bit deeper into all of this to see what kind of quantifiable measurements might be able to be applied to this. So you can see that here is my last point. Are there any specific rates of increase that we can really apply here? I know that there's been some work and research done, but what specifically can we really apply from an operational standpoint that helps out the mesoanalyst and the radar operator to determine, yes, there might be a blip of lightning, but what does that tell me, right? So what specifically can we really pull out of this information to help us improve operations? So that's what I was looking at here. That's pretty much all I've got. I just want to thank you once again. The picture that I have up here is a lightning survey. It was the very first survey, as well as a tornado survey that had occurred that same day that I had done in the Weather Service, and this was down in Melbourne. Extensive lightning had occurred, and so this was in Werner Park, Florida, back on July 15th, 2009. So this was very interesting to see very early on in my career. And really the main goal is what can we maximize with the lightning data? How can we use this information and working together to get the warning out as quickly as we can to people. So like I said, that's all I've got. Thank you very much for your time, and definitely here for any questions.